This is Lesson 9.2, Multiplying Polynomials. First, we're going to look at multiplying a monomial, that's one term, and a polynomial. So to multiply, you're going to distribute the monomial to every term in the polynomial. You're going to multiply by everything within the parentheses. Multiply all the coefficients, and remember, you add exponents when multiplying the same bases. So here, in example 1, we have 2x squared times the quantity x to the third plus 3x squared minus 2x plus 5. We're going to use the products of powers property, and we're going to multiply the 2x squared first by x to the third. That becomes 2x to the sixth. Then we multiply it by 3x squared. We get 6x to the fifth. Then minus 2x, that's minus 4x to the fourth, plus 10x to the third. Now you can multiply polynomials vertically or horizontally. Normally I do it horizontally, but maybe you would want to do it vertically, so we're going to take a look at that. So in example 2, we have b squared plus 6b minus 7, and we're going to multiply it by 3b minus 4. So first you're going to multiply all the terms in the top row by negative 4. So we get negative 4b squared minus 24b plus 28. And then we're going to multiply all the terms in the top row by 3b. So we get 3b cubed plus 18b squared minus 21b. And then you're going to add like terms together. So you add all the cubed terms, all the squared terms, and then all the b terms. And you end up with 3b cubed plus 14b squared minus 45b plus 28. If you're going to multiply horizontally, we usually use the FOIL method. And the FOIL method stands for first, outer, inner, last. So when you take a look at this example, 2x plus 3 times the quantity 4x plus 1, you have to multiply first the 2x times the 4x, and you get 8x squared. Then the 2x times the 1, that's the outer term, and you get 2x. Then the 3 times the 4x to get 12x. And then the 3 times the 1, which is 3. You have to combine those two middle terms. You see you have two x terms in the middle, so that you get 8x squared plus 14x plus 3. In the next example, we have 3a plus 4 times a minus 2. Again, we're going to multiply first, outer, inner, last. So the first is going to be 3a times a, that's 3a squared. Then 3a times minus 2 is minus 6a. Then 4 times a is 4a. And 4 times minus 2 is minus 8. And then you have to combine like terms, which are the two center terms. That's minus 6a and 4a. And that becomes minus 2a. So you end up with 3a squared minus 2a minus 8. In the next example, we have some negatives in the first parentheses. So we have 4x minus 3 times the quantity 2x plus 1. And again, first, outer, inner, last. So it becomes 8x squared plus 4x minus 6x minus 3. You combine those two terms in the middle, the two x terms, and you get 8x squared minus 2x minus 3. FOIL is really useful for area calculations. For example, if you have a rectangle whose dimensions are a width of x plus 3 and a length of x plus 2, you could find the area by multiplying the length times the width. That's x plus 2 times x plus 3. And when you use FOIL to multiply, you're going to get x squared plus 3x plus 2x plus 6. And that's x squared plus 5x plus 6. Take a look at this word problem. This is a skate park area. So there's a skate park, that's that middle part, okay, with a walkway that goes around it with the dimensions as shown. So we're going to have a walkway on the top, the side, and the bottom, and that walkway has a width of x. The length of the sidewalk from top to bottom is 33 feet, and the width going across is 45, but of course that includes the sidewalk. So what we want to find is the area of that park in the middle. So the area of the park has to be the total area minus the area of the walkway. So you can build the walkway area into your calculations. If you look at length times width, well, the length of the park is 45 minus the x, that's that sidewalk on the right-hand side. And the width is the 33, which is the whole thing, the sidewalk, the park, the sidewalk, or walkway. So that's 33 minus 2x. You've got an x on the top and an x on the bottom. So you have to subtract those two x's to get the actual height of the park. In other words, we're looking at this part right here. Okay? This part right here. So we're going to take the 33 and we're going to subtract the two x's, and that way you end up with this area. And we also are looking at this width here. Okay? So that width is going to be the 45, and then you're going to subtract the x that's on the end. When you multiply these out, 45 minus x times 33 minus 2x, you get 1485 minus 90x minus 33x plus 2x squared. Put all those terms in the correct order. Remember, the highest exponents go first, so it's 2x squared minus 123x plus 1485. Now, what if the walkway were 3 feet wide? Well, you could substitute 3 into the equation to get an actual number for the square footage that represents the area of the skate park. So we're going to put 3 into that equation we just developed. So it's 2 times 3 squared minus 123 times 3 plus 1485, or 18 minus 369 plus 1485, or negative 351 plus 1485, or 1134 square feet.